So what we're going to start with first to review, we're going to start with the exponent law and simplifying expressions. Okay? So exponent law is one of the units or one of the lessons that you learn in grade 11. Okay? And do you guys remember any of these laws? Do you remember where, like, how can we use them? When can we use them? Anything like that? So most of these laws that you see right here, they are on the wall right here as well, okay? And these laws can be used when we are trying to simplify expressions if they have the same base, okay? So for example, if I have x to the power of 8 multiplied by x to the power of 3, right? Because I have two terms that have the same base and I'm multiplying them, I can simplify this. What would this simplify to?
So I keep the base
Yeah?
and add the exponents.
Correct. So we're going to keep the base. Because I have the same base, I can do that. I keep the base, and then I add the exponent, so 8 plus 3, right? Which is going to give me x to the power of 11. Okay? And that can happen for every time I have the same base and I have a multiplication. I can keep the base and add the exponent, right? So for example, if I have 2 to the power of 9 times 2 to the power of 5, what's 14? Do I just write 14 or 2 to the power of 14? Okay? So the important part here is that your base is the same, so you keep it and then you add your exponent. Okay? This is a multiplication law. So this is what you see here as your first law. Okay? So where you have the multiplication law, you have the same base and there's a multiplication, you add your exponent. Okay? Do you guys know why that happens?
Because it's just multiplying itself anyway.
That's right. That's right. So if I go back to this page, right, and I want to expand one of them, doesn't matter. If I want to expand this one, for example, and then I have x to the power of 8, so that's x times x times x times x. Right? 8 times, that's what x to the power of 8 is, right? Multiplied by another x cubed. So that's multiplied by x, right? So you see I have now 11 x's multiplied together, which simplifies to x to the power of 11. Right? Now, the second law is the division law. Okay? So if I have a to the power of m divided by a to the power of n. So again, we're talking about same base, okay, and I'm dividing. So in this case, if I want to look at this, right, so if I have a to the power of 5 divided by a to the power of 3. Okay, if I want to write this in expanded format, I have a times a times a times a times a divided by a times a times a, right? And that can be simplified. Right? Because I'm dividing, I can eliminate. So that will end up with, what do I end up with? A to the power of 2. Okay? So what's happening here with my exponents? Subtract, right? So I keep the base, I subtract the exponent. Okay? So whenever I'm dividing, as long as they're the same base, I keep the base and I subtract the exponent. So that's what the division law says. Are we okay with that? Okay. Then we have the power of a product. Okay. So in this case, what I have, so if I have, let's say, 2x y squared to the power of 3. Okay. You see that inside the bracket, there's all are multiplied. All terms are multiplied together, right? 2 is multiplied by x by y squared. So in this case, what I can do is I can distribute that 3 in, right? By distributing that 3 in, you're multiplying your exponent by your exponent. I should teach you the power of the power law first, just because then this will make sense. So if I have, for example, a to the power of 2 to the power of 4, what do I do here to simplify? Multiply the exponents. Okay? So think about this as a squared, a squared, a squared, a squared. Right? That's what this means. A squared to the power of 4 is a squared multiplied by itself 4 times. Okay? What did we learn earlier? If I have multiplication, what do I do with the exponent? Add them. 2, 4, 6, 8. Right? If I have multiplication, you add your exponent, as long as you have the same base. So 2 plus 2 plus 2 plus 2, that gives me 8. That's the same thing as actually, instead of writing it in expanded format, that's the same thing as multiplying my exponent. So it's going to be a to the power of 8. So I can do a, 2 times 4, which gives me a to the power of 8. Okay? So that's the third law that we should learn. Let me put it here. That's this law right here. The power of a power. Okay? When you have base a to the power of m to the power of n, we multiply the exponents. Are we good with that? So I'm going to go back to now this law, which is power of a product. You guys stop me if there is anything that doesn't make sense and you need me to repeat, please. Okay? So the power of product, so I had 2xy squared to the power of, what was it, 3? The question that I wrote earlier. So that's the same thing as if I have a squared to the power of 4, right? So I have an exponent outside, but I need to multiply that exponent by every exponent inside. Okay? But I have to remember here that all the letters in the numbers are going to be affected. Okay? What would be the exponent on x? 1. What would be the exponent on 2? 1. So if you don't have an exponent, it's an invisible exponent of 1. Now, look what happens. I multiply that 3 by each exponent in the bracket. So that's going to become 2 cubed x cubed y to the power of 6. Okay? So that's what we're doing. We're distributing that exponent into every single letter and variable and number inside my bracket. As long as I have a multiplication inside the bracket. Are we okay with that? Okay. A lot of times, people forget to, they remember to bring in the cube to the letters, but they forget the number. They forget the coefficient, and then they leave the coefficient as is. That's most of the mistakes where that happens when it comes to a question like this. So that's why I tell my students, put an invisible 1 on every single thing inside that bracket that does not have an exponent. That will remind you that you need to multiply the 3 into every single thing. All right? Are we good with that? Now I can simplify this if I want to simplify, right? Because 2 cubed is 8, x cubed, y to the power of 6, and that would be my final answer. Are we good with that? So, the power of a product is ab to the power of n. So what's happening is that they're bringing that n in. There is an invisible 1 on the a and the b. So when you multiply n times 1 gives you n times 1 gives you n. So that's why you end up with a to the power of n times b to the power of n. The same rule apply when I have a quotient. So when I have division, okay. I know I added this into your notes. There is a mistake here. So the same rule applies when I have a quotient. Okay, so if I have, for example, 2x over 5y to the power of 4. If I have this, for example, okay, that cube has to be distributed to everything inside that bracket because I have a division and multiplication here, okay? That has to be multiplied in. So anything that doesn't have an exponent, I'm gonna put an exponent 1 on top of it. And then I'm gonna multiply my 3 to each exponent inside the bracket. So that's going to be 2 to the power of 3, x to the power of 12 over 5 to the power of 3 and y to the power of 6. Is this clear for you guys? So, if I have multiplication inside my bracket, division inside my bracket, I can distribute my cube. Now, question for you guys. How about this? Can I distribute my cube? It's a minus there. Can I distribute?
Yes.
Is it multiplication inside the bracket? Is it division inside the bracket? Then I cannot. Okay? This is the same thing as, I don't know if you remember, like when you did probably the grade 11, right? If you had, let's say, a minus 2 squared, right? You had to expand this. To expand this, you had to write it twice, right? I don't know if you remember this. So you had to write this twice. Oops. And then you had to, what do we call the process? Distribute over 4 squared minus 2a minus 2a plus 4, right? And then collect like terms, a squared minus 4a plus 4, okay? So whenever you have that subtraction or addition or whatever inside between your terms, you can't just simply distribute your exponents in. Does not work. Because if I do that, I'll be missing my middle term. Okay? Same with the cube. If I have a minus b cubed, guess what I have to do? I have to write it 3 times next to each other, and I have to FOIL so many times. Okay? So in this case, I cannot distribute, I cannot do this. This is wrong. Are we okay with this? All right. So far we went with the power of a product, power of a quotient. When I have a power outside, I distribute my power in. Anything to the power of 0 is 1, right? Could be a number, could be a letter, could be expression. Anything to the power of 0 is 1, okay? So anywhere you see, like let's say you have x minus 3 to the power of 0, that's equal to 1, okay? If you see 10 million to the power of, I don't know what that number is, to the power of 0 is 1, okay? Do you guys know why? Do you want to know why? Not care? Okay, here's some. Okay, so let's have a cube over a cube. How would you simplify that? A to the power of 0, and what did you do to get that? subtract the exponent because I'm dividing. Right? I'm dividing, I keep the base, subtract the exponent. That gives me a to the power of 0, right? Okay. What if you don't want to subtract the exponent? When you have a cubed over a cubed, what is it equal to? 1. Right? When you divide something by itself, if you have 5 divided by 5, that equals 1. 20 divided by 20 equals 1. Right? So no matter what you have, as long as you're dividing it by itself, it's going to equal 1. Right? So this case here, a to the power of 0, right? Or if I want to just do the simplification, that's going to equal to 1. So that's why anytime when you get a 0 as your exponent, your answer is going to be 1. Okay? All right. Now, with negative exponent, anytime you have a negative exponent, you cannot leave your answer with a negative exponent. It is not a proper notation, so we have to always change our negative exponent into positive exponent. And to do so, you have to flip your base and make your exponent positive. Okay? That's the rule to make it a positive exponent. All right? So, let's look at an example here. So if I have, let's start with a simple example. So let's say if I have x to the power of negative 2, okay? Because my exponent is negative, I have to flip my base. So the base is x, or x over 1 if you want, right? You're going to flip that base and it becomes 1 over x, and you make your exponent positive. Okay? I'll show you why is that. Okay, but then for the rest, you're going to have to understand that whenever you have a negative exponent, you're going to have to change the location of that base. We'll talk about it a little bit more. Look at this. So if I have x cubed over x to the power of 5, what do I do? How do I simplify this? Subtract the exponent. So that's going to give me x3 take away 5, which is x to the power of negative 2, right? But if I want to use my simplification, right? My expanded format. So if I want to expand this, that's going to be x over x, and then 1 more. Okay? I'm just expanding this. All right? Now, if I want to simplify, cancel, right? And what I'll be left with is I have nothing on the top, so that's a 1, over, and I have x squared at the bottom, right? These are exactly the same question. Okay, these two are the same question, right? One I use the exponent law, and the other one I use the expanded format. Okay, so that tells me that these are equal. Okay, so anytime you have a negative exponent, you want to change the location of that. You want to flip your base. Okay. Now, what if I have something that looks like this? What's the first thing I have to do? Flip the base, make my exponent positive. The whole idea of flipping is to make your exponent positive. So flipping means you're going to flip your numerator and denominator and make, basically you're going to, your denominator is going to become your numerator and vice versa, and that makes it positive exponent. Okay? Now when it's positive exponent, you can distribute. Okay? Do not distribute a negative exponent, please. Okay? Because then it's going to mess up your numbers. I don't care about the letters because the letters are easily manipulated, but the numbers, they're going to become a little weird when you distribute a negative exponent. Okay? Are we okay with this? We'll I will review this with you. So this is not going to be something that, I'm just gonna explain once and then move on, okay? And by the way, this is like almost 2 lessons in my unit, in grade 11, so I'm moving a little fast. If you wanna distribute that in, as we did earlier, what would you do?
The exponents on every.
Yeah,
thing.
put an exponent of 1 on everything, okay? And multiply the 2, right? To the exponent. So that's gonna be 3 squared, y squared, z squared over 2 squared and x squared. Okay? Now the other thing that you need to know about negative exponent is if it's like sense. Let me just show you this. So if I have this, so it's not the whole thing that has a negative exponent, it's special things that they have negative exponent. So what happens here?
So make the exponent be positive first, right?
Yes, and how can I make the exponent positive?
To flip the exponent has a negative down and the z up.
Okay, so you mean like to
Change that.
bring whatever has a negative exponent from the top, bring it down to the denominator, and then whatever is in the denominator, bring it up to the numerator. Yes. Okay, so whenever you have a negative exponent on a letter specifically or on a number specifically, you can change its position. Okay, so if you have a negative exponent and it's in the numerator, you can simply bring it down to the denominator and make it positive. Okay, so that right here, 2 is gonna stay, the 3 is gonna stay there because it has exponent of 1. The x to the power of negative 2 is gonna come to the denominator and become positive exponent. How about the y to the power of 4?
To keep it.
Stay there because it's already a positive exponent. And then the z to the power of negative 3 has to come to the numerator and becomes positive. Okay? So they change their location from numerator to denominator or vice versa if they have negative exponents. Are we good with that? All right. So that covers both negative exponents. So this is, you always want to simplify first and then evaluate, okay? Don't start evaluating until you simplify. So if I look at my, my example right there, so I have 7 to the power of 2 multiplied by 7 to the power of negative 5 divided by 7 to the power of negative 1. What would you want to do with this question?
Flip the exponent. Flip the negative exponent.
You can do that, yep. So you can bring the, so what would you do? Tell me. So if you want to flip the exponent, so what comes up, what comes down? So the 7 to the power of negative 1 is going to come up and become 7 to the power of 1. And the 7 to the power of negative 5 is going to come down and